elbow partner, sorry, an elbow partner. A heading you and your elbow partner saw. Serena.
We put genotype.
Genotype. Okay. Adam, an elbow part. I did it again. A heading you and your elbow partner saw.
Mix and match.
Mix and match. And Serena, you said
Genotype.
genotype. There's one that sounds similar to that, so I want to make sure I have the right one. Yusuf Shami.
Wait, I don't think I got this.
Pardon?
I don't think I got one.
You have no
I
five
had
heading.
one.
Okay. Amen.
Unraveling the mystery.
Unraveling the mystery. Mysterious. Galiana.
Who was Jero Mendel?
Who was Gregor Mendel? And Sarah?
Many genes, one trait.
Many genes, one trait. What are two things we already know looking at the headings? Ryan Shammy. You didn't get to that part yet? Okay, that's fine. Make sure we're writing stuff down. Hassan,
Self, how many can plant?
is that a heading or what's something you already, we're looking for things we already know.
Oh,
The middle column.
I gotta get that.
Okay, we did get to it. Let's do volunteers. Why is my... Okay, you're saying, okay. So headings are many titles, okay? Many titles. Many titles. Let's try to focus on something in the content that we already know. Say,
Genes are found in DNA.
genes are found in DNA. Okay, what are questions we have? Questions we have after looking at the headings. Ryan Dazzy.
With the headings, I said, what is Mendel's experiment?
What was Mendel's experiment?
Yeah.
Okay, that was one of the headings. I'm glad you asked that question, Ryan. What is Mendel's experiment? And then Ahmed. What's a question you have? Okay, Hussein Hashem.
I don't have a question.
Okay, let's do a volunteer for questions now. Brianne,
When it says unraveling the mystery, what is the mystery?
what is the mystery? That's a great question. What is the mystery? I really like how you thought about that heading and thought, what is that mystery? What are they talking about? Really like that. Okay, everybody, so we are going to watch a Brain Pop video. It's about heredity. And while we're watching the Brain Pop video, we are going to be doing a 3, 2, 1. So the 3 is for 3 facts you learned. The 2 is for 2 interesting details. And the 1 is for 1 question you still have. So I know the Brain Pop talks super fast, so I'm going to show you the video 2 times. I'm also going to have the closed captioning on. And what we're going to do is I'm going to show you once. I'll give you some time. And of course, I want you filling it out why we do it. And then I'll give you some time to write after the first viewing. And then we'll stop and we'll think about how we're going to strategize filling it out the second time. My suggestion is for the number 1, the 1 question we still have. Is that something that we need to focus on the first time through the video? No, so we could probably just save that one for the very end. Okay? So I want you to think for a second. You have 5 things that you have to write down during the video, right? So think for a second about a plan of attack that you have to get those 5 things written down into video when I show the video to you 2 times. Think about how you're going to attack that and get those 5 things down. When you have your strategy, give me a thumbs up. When you have your plan, give me a thumbs up. Hussein Awada, how are you going to do this?
I'm probably gonna wait till the end to do my question. I'm gonna listen to the video for interesting details, and at the end I'm gonna go fast along.
So you're focusing on the interesting details first, and then at the end you're going to do the facts and the question.
Yeah, after I learned what the video told me.
Okay, that's one way. Let's see, somebody else. Nora, what are you going to do?
So I'm gonna try on the first time. I'm gonna try to get as much fun facts and details as I can and write half of them if I can't get the whole thing. And then on the second part, I want to rehear it to make sure that I can finish what I wrote.
So you're going to try to get done as much as you can the first time, and then the second time through, you're just going to kind of like check for understanding and make sure you didn't miss anything. Okay, that's a good plan too. Anyone else have a different plan besides that? Sarah, what's your plan?
For the first time running through the video, I'm just going to listen to it, and then after, for the second video, I'll be writing down the facts that I learned and the interesting details, and then all the way at the end, I'll do my question.
So your plan is just the first time through, just to listen. And then the second time through, that's when you're going to write the stuff down that you need to. I like that idea too. All right.
Dear Tim and Moby, my parents both have brown eyes, but mine are blue. What's going on? From Tyra. Well, I bet there are blue-eyed people somewhere in your family tree. Eye color is just one of many physical traits we inherit from our parents. That passing of traits from parents to offspring is known as heredity. But remember that parents inherit traits from their parents, and so on, as far back as your family tree can go. Let's look at some pea plants to see how it all works. Yes, pea plants. Every living thing inherits traits. Back in the 1800s, a monk named Gregor Mendel used pea plants to study how
There you go,
traits like
Ryan.
height, color, and shape are inherited. When Mendel crossed short plants with tall plants, he noticed that only tall plants were produced. Whatever produced these short plants seemed to disappear. Mendel called that tall height trait the dominant factor because it dominated or covered up the short height form. He called the short height trait the recessive factor. By the second generation of pea plants, those recessive short plant forms cropped up again. After tons of research, Mendel was able to predict that, on average, 1 out of every 4 pea plants would be short. Each plant has 2 genes that determine height. The tall gene, represented here by a capital T, is dominant, which means it only takes 1 of these genes to make a plant tall. It takes 2 short genes, represented by a lowercase t, to make a plant short. In the 19th century, a British geneticist named Reginald Punnett also experimented with peas and developed something called the Punnett square. Among other things, this Punnett square lets you predict the likelihood of what you would get if you crossed a tall plant with a short plant. An offspring gets one gene from each parent, either a tall or a short gene. Each plant produced by these two plants will be tall because each one has one of those dominant tall genes. But what happens if two of these new plants produce offspring? There are lots of ways this could turn out, but the most likely result is that we get 3 tall plants and 1 short plant. Mendel only figured this stuff out after carefully studying 30,000 individual pea plants over an 8-year period. Well, I guess it's pretty reasonable to assume that he had peas for dinner every night. I think you're missing the point.
Ugh.
Bobby?